Hey everybody, Mr. May here, coming at you with another video. Today we're going to talk about day 3 notes, which is on properties of logarithms. The first part of the notes is using the yellow calculators from class. There's going to be a video posted along with this video detailing how we're going to use Desmos to complete these examples here. So what you want to do for this video for the notes is go ahead and skip it, but watch that second video later to complete the rest of the notes. We're going to go ahead and talk about the properties, starting with this. We're going to talk about product property, quotient property, and power property, and how we're going to use those properties to expand and condense log expressions. To expand log expressions, the first thing you need to do is split up all the quotients, then split up the products, then split up the powers. You want to follow that order exactly. If you don't, you're going to have a situation where you're going to get lost because you jumped ahead. For example, if there's a example in which there's division and multiplication and there's powers, and you skip the quotient and went straight to the products, you're going to get lost. So, what is product property? Product property is if you had 2 or more values in a log, you can split all of them up to create an addition example, and vice versa. Quotient, if you had a division within the log, you can split them up to create a subtraction, vice versa. For power property, if you have a value being raised by an exponent, you can expand that by putting that exponent in front of the log to create a multiplication example. So we're going to use those properties to expand or condense logs. All right? So refer to this page when you complete examples later on, and especially when I refer to here's step 1 or step 2, refer to this page for that. First thing we're going to talk about is expanding a log expression. So the first thing you want to do is identify if there's any quotients in the example. There are no quotients in this example, so we can go ahead and skip that and go straight into talking about product. Is there anything being multiplied within the logs? And the answer is yes. We have x to the 4th and y to the 6th. So we're going to expand that. So now we have log base of 3 of x to the 4th and log base 3 of y to the 6th. How you split them up is through addition. If you refer back to the previous page, you'll see that product properties, when you have anything multiplied, they're split up into an addition example. So that's step 2. Now step 3 says, are there any powers? And the answer is yes. You want to bring those powers in front to be multipliers. 4 times log base 3x plus 6 times log base 3y. If there's nothing left to do, where you have any products, if there's no products, quotients, and powers, then you are finished. That's how you know you are done with expanding the log expressions. If you have no more quotients, no more products, and no more powers. So next thing is natural log. Natural log, same thing, guys, same thing for logs, is that you need to use those properties. The property still plays here, even if natural logs. The first thing you want to do is identify, do you have any quotients? This time we do have a quotient. We have x to the 3rd z squared all divided by y. We're going to put the numerator in one natural log. And then we're going to put the denominator in their own natural log. And how you separate them is through subtraction, which you can see from the previous page. Notice I didn't expand the product because that's not what you're supposed to do first. You're supposed to expand any quotient. Now that we've done that, we can expand the products. So they're going to be in their own natural log. All right. Finally, are there any powers? Yes. So bring them down, put them in front. Now you have 3 times natural log of x plus 2 times natural log of z. Oops. Z. And you have minus natural log of y. Now, we're going to talk about condensing later, but if you were to condense all of this, you would follow those steps exactly. You should get back the starting example on number 2. Back over to number 3, we have log of x squared times the square root of y. There are no quotients in this example, so we skip step number 1 and go to step number 2, which is expanding products. All right. This square root of y can be rewritten, and you want to rewrite that as y to the 1/2 power. All right. So we're going to rewrite this as log of x squared plus log of y to the 1/2 power. That's going to be important in the later example when you have 1/2 in front of the logs and you have to condense things. So that's going to be really important. Now that we've expanded and split up the products, now we have those powers, so bring them down to make 2 times log x plus 1/2 log y. And you're done. Finally, number 4, because we have this 6 on the outside here, we're going to use something that we used way back, which are the exponent laws. We can rewrite this by distributing that 6 into the other exponents. So we're going to multiply 2 by 6, and there's a 1. There was a 1 here for that y, and now we're going to multiply that 6. So rewriting this as log base 3 of x to the 12th y to the 6th. All right. Split them up because there's no quotient, but there are products, so split them up as log base 3 of x to the 12th plus log base 3 of y to the 6th. All right, and we have powers here, so put them down in front, and now we have 12 log base 3 of x plus 6 log base 3 of y, and you are finished. Okay, so that is all there is about expanding. Any questions, give us a shout. Now we're going to condense the log expressions. First thing you want to do is identify if you have any powers by looking at the bigger numbers in front of the logs or the natural logs. Here we have 6 and 18. They were originally powers. You want to bring them back to where they were before you brought them down in front. So log base 3 of x to the 6 minus log base 3 of y to the 18. This should be log base 3 right there. Now, you want to see, is there any addition or subtraction? If there's addition, that means there was originally a product. So you want to bring them back together to create a product. If there was any subtraction, you want to bring them back together because that originally was a quotient. So you want to make a division. This here we have subtraction. So we need to make a quotient. We need one log only. That's our goal when we condense. So when we bring them all together, now we have one log base 3. This x to the 6 came first, so that goes on top, and y to the 18 came second, so that means it's on the bottom, and we are finished. There's no addition, there's no more subtraction, there's no more number from the logs. We've condensed everything to make one log, and that's our solution. Number 6. We had that 5 in front, which was originally a power, so bring them back. We have natural log of x plus natural log of y plus natural log of z to the 5th. We have addition everywhere. So all of this with addition means that all of this was originally a product. So we're going to make them all into one natural log. When now we have x, y, z to the fifth, all within this natural log, and we are done. Yay! Finished. Finally, last one. We have 1/2 in front of here, so they're going to go back up here with their respective y and z. So we have log base 7 of x plus log base 7 of y to the 1/2 plus log base 7 of z to the 1/2. And remember, that 1/2 means that they were a square roots. We have addition throughout, which means that this is a product. So we have log base 7 of x times square root of y times square root of z. But we can bring together this square root of y and square root of z so they're inside only one radical, because we also want only one radical. And here we are. Okay? And this is how you condense logs. Okay, so any questions, give us a shout. On this page, what we're going to do is use the given information to complete and find these sort of examples. You need to refer to the product, quotient, and power properties in order to complete these. I want to go over a couple examples, and then I'm going to let you guys finish the rest of this, okay? So, first thing you want to do is use the given information up here. See if you can either multiply, divide, or raise to a power to get you 54. When I say these, I meant these numbers. Can you multiply any of them? The answer is yes. 9 and 6. 9 times 6 is equal to 54. So I can rewrite log base 5 of 54 as log base 5 of 9 times 6. By the product property, we can split them up, okay, and make log base 5 of 9 plus log base 5 of 6. As we see, log base 5 of 9 is 1.4. Log base 5 of 6 is 1.1. Now we just add them up, which means log base 5 of 54 is equal to 2.5. Nice. So what we did was just basically just made a little puzzle. We solved a little puzzle here. Did some investigation work, boom, we got it. So let's look at another example. We have to find, you have to find log base 7 of 81. Anything here we can multiply, divide, or raise to a power. This 9, actually, we can raise this 9. 9 squared is equal to 81. So we can say is log base 7 of 81 is equal to log base 7 of 9 squared. Based on the power property, we can bring that down in front and make 2 log base 7 of 9. Log base 7 of 9 is 1.1. 2 times 1.1 is 2.2, which is equal to log base 7 of 81. Okay? So use this stuff, use these examples, use the quotient of property, product property, and power property to complete the remaining examples, and refer to the key that I'll post later. Okay? And don't forget that first part, refer to the other video involving Desmos. Alright? Alright guys, we'll see you later.